Okay, grade 8, now we're on the first section of space and shape. We're going to start off with geometry of 2D shapes, and specifically we're going to be talking about triangles. We're going to furthermore get into what similarity is, congruency. We're going to then look at a couple of quadrilaterals and their properties. Let's get straight into triangles. Okay, we have three main types of triangles. An equilateral triangle. This is where A equals B equals C, all the sides are equal. We're going to put a line there to show that all the sides are equal. And then we can say X equals Y equals Z equals 60 degrees. Right? We can also label these angles all the same letter. For example, that could be simply written as XXX. We're going to just write here X, Y, and Z is all equal, and that is all equal to 60 degrees. We then have an isosceles triangle. This is A, B, and C, the lengths, where two of the sides are equal. For example, A and C might be equal. This also has two equal angles. In this case, it would be Y and Z. Then lastly, a scalene triangle. We have A, B, and C. This is where no sides are equal, neither A or B or C, and none of the angles are equal, neither X, Y, or Z. So here we can write these as those two are equal, and that is an individual one. And here we can write this as 1, 1, 2, and 1, 2, 3. This is to show that that is different to that is different to that. These two show that those two are the same, and this shows that all three are the same there. This is good practice when drawing triangles. There's also three main angle types of triangles. So you get an acute triangle. This is where all the angles are less than 90 degrees. A good example is the one we just did where this was 60 degrees, 60 degrees, and 60 degrees. All the angles are less than 90 degrees. Or you get a right angle triangle where one of the angles is equal to exactly 90 degrees. Now when we have a 90-degree triangle, we draw it like a square in the bottom left there. It has to have a right angle. We call a right angle a 90 degrees triangle. So don't forget that right angle we put as 90 degrees. Okay, and that is a quarter square as you would on your protractor. Then we have obtuse. An obtuse triangle is where one angle is more than 90 degrees. Here you can see that X is more than 90 degrees. And this is an obtuse triangle. So when we name a triangle, we use two names to describe it most of the time. So triangles have three sides, A, B, and C. Right? The perimeter of a triangle is simply P is equal to A plus B plus C. That makes sense. The perimeter, the length of the outside wall, is A plus B plus C, the length of those three sides. Then we have a triangle, also with A, B, and C, where the area of the triangle is a half base times height. Half base is our B here. We've labeled it as base. So it's that length over there. Half of that base times the height. Now make sure you watch our other videos to really get a good understanding of why this is in fact true. Make sure you watch our properties of triangles where we show that this is in fact half a rectangle, and that's why you get our half base, because base times height is the area of a rectangle, and we can show that a triangle creates a rectangle and it's half of that area. But make sure you watch our video specifically on area and perimeter of triangles. This is just going over it. And then we have the angles X, Y, and Z. As you can see here, X, Y, and Z, X, Y, and Z. And they're always equal 180 degrees. And when I say always, I mean always. Never think that a triangle equals anything else. Okay, now this is a very important slide. Pause the video here if you need to. This is going to tell you everything you need about triangles. Like I said, a triangle is made up of two names. First, looking at the geometry of the triangle. This is about the sides, and then the angles of the triangles. So remember we had equilateral, isosceles, scalene, acute, right, and obtuse. Okay, so equilateral, everything is equal. All the sides are equal. We have an equal side, an equal side, and an equal side. We have an isosceles triangle where two sides and angles are equal. So here we have that is equal, that is different, and these are equal over here. Oops. These are equal here, and then this will be different. We've got two lines there that shows a different angle. Then we got a scalene where nothing is equal. That's 1, that's 2, that's 3. These are 3 different angles, A, B, and C. Right? Nothing is equal. Then we have acute, where all the angles are less than 90 degrees. A good example is our equilateral triangle with 60, 60, 60. Then we have a right angle where there's at least one angle with a right 90-degree angle. We put a square there to show it's right, because a square has right angles. And obtuse, where one angle is bigger than 90 degrees. And you can quite easily see that this angle here is bigger than 90 degrees. So, we also get an acute equilateral triangle, and that is your easiest triangle to know or to remember. It's acute equilateral. It means all the sides are less than 90, and it's all the sides are the same length. It's almost overstating the name of the triangle, but just remember this is an acute equilateral triangle. We're saying the name of the angle first. And that will look like this. All of these are equal, and all of these are equal over here. We don't have a right angle equilateral triangle. If it's a right angle, you can't have equal length sides. The same goes for obtuse equilateral. This triangle can't exist. That's great. This saves us a bit of time. Let's now look at an acute isosceles triangle. Acute, all angles are less than 90. Isosceles, 2 sides are equal and an angles are equal. So here we have 2 equal sides, just like this one here. We have a third side that's not equal. 2 angles are equal, and then we have 2 angles equal here. A third angle that's not equal here. Now, none of these angles are more than 90 degrees. All of them are less than 90 degrees. Then we could also have a right angle isosceles. This is where this length is equal, this length is equal. This is at 90 degrees, that's less than 90. Those are those will be 45 degrees, and this is a different length here. Quite a common triangle. And then we have an obtuse isosceles triangle. This angle here is more than 90 degrees. These 2 sides are equal. This is a third length side over there. And then we have 2 equal angles over here. There's an equal angle and there's an equal angle. Now we have an acute scalene triangle. So this means nothing is equal, no sides or angles, but all of the angles are less than 90 degrees. So this could be 45, 55, and 80, for example. And none of these lengths are equal either. Then we could also have a right angle scalene triangle. So these 3 are all different here, different lengths. And this angle is different to this angle and obviously not equal to 90 degrees. Then we could have an obtuse scalene triangle. This would be all 3 different lengths and all the angles are different as long as one angle is greater than 90 degrees. So this, grade 8, is a very important slide. Remember it, pause the video, see if you can draw this yourself on your own piece of paper, make a table 4 by 5 and draw it. Let's look at some examples. Solve Z. Okay, so we have a triangle. We've got to solve the Z angle. Now we know that A, or let's call it X, plus Y, plus Z is always equal to 180 degrees, right? So we know that Z is equal to 180 degrees minus X and Y, minus X and Y. What is X and Y in this case? It's 180 degrees minus X, which let's call X 44, let's call Y 92. So what do these minus each other add up to? So what is 44 plus 92? That's 136 minus 180. So 136 or 180 minus 136 is 44. Oh, these are exactly the same over here. Okay, that's interesting. So this Z is equal to 44 degrees. You can put your degrees sign above it. Let us name the triangle. What would the name of this triangle be? So we can already see that there's 2 angles that are equal, but one angle is definitely more than 90 degrees. So this is obtuse. Obtuse. So it's an obtuse. What kind of triangle is if 2 lengths are equal, 4 and 4? This is an obtuse isosceles triangle. Isosceles triangle. Okay, let's look at another example. A triangle has the following angles, 40, 50, and 90 degrees. Name the triangle. Let's have a look at this table to help. Is it an acute? Yes, yes. Oh, no. Oh, there's a 90. It must be a right angled. Must be right angles. Is it equilateral? Is it isosceles or is it scalene? Okay, now this, we can see that none of the angles are equal. Now, an equilateral has all three angles equal, and an isosceles has at least two angles equal. So this must be a scalene triangle. So it's going to be a right-angled scalene triangle. Previously, we had obtuse because it was more than 90 degrees, and isosceles because there were two angles that were equal, or two sides as well that were equal. Both of them are giveaways. Okay, let us solve y. Right? So how do we solve y? Okay, we can quite easily see that this has two equal angles. Right, now if there are two equal angles, this immediately makes it an isosceles triangle. An isosceles triangle also has two equal sides. Because these two angles are equal, it means that these sides here must be equal. So we can very easily see that y is equal to 2. Now how can we name the triangle? I'm going to tell you that x is equal to 41 degrees. So it's 41 degrees here, 41 degrees here, right? So what would this angle be over here? So that angle there is 180 minus 2 times 41. So that's 180 minus 82, which is equal to 98. Okay, so we can immediately see there's an angle bigger than 98 degrees. So it's immediately going to be obtuse, isosceles, because we know it's an isosceles. Okay. Let's have a look at the last example. A triangle has the following angles: 140 degrees, 10 degrees, and 30 degrees. Name the triangle. Remember quickly, I haven't written this very neatly. So that is an obtuse isosceles triangle. Obtuse because we had an angle more than 98 degrees, and isosceles because there are two equal angles and two equal sides. Now what is happening here? This also is going to be an obtuse because it's got an angle more than 180 degrees, and then it's going to be a scalene because none of the angles are equal. So this is an obtuse scalene triangle. Well done, grade 8s. That is triangles. We're now going to move on to similarity, congruency, and quadrilaterals. This is going to be mostly dealing with triangles too. If you battled with some things here, make sure you watch the videos in the previous section on how to do area and base and perimeter of triangles. Well done.